Welcome to Cosmic Compass, the channel where we journey together through the wonders of the universe, from distant galaxies to the secrets hidden in our own solar system. We explore the stories that shape our cosmic neighbourhood. Today, let's look closer to home and ask a curious question. Does Earth really have only one moon? Or are there hidden companions drifting silently through space that most of us never notice? With countless asteroids racing through the solar system, it almost feels like a miracle that Earth has only one moon. When we look farther out beyond the inner solar system, things look very different. The giant planets Jupiter, Saturn, Uranus and Neptune have dozens, even hundreds of moons. Some are large, round and stable. Others are strange, irregular companions with tilted, eccentric orbits, sometimes even moving backwards compared to the regular moons. So here's the question, could Earth ever have more than one? And if so, how come we don't notice them in our night sky? Let's explore. Irregular moons are a fascinating group. Unlike the regular satellites which form alongside their planets and orbit neatly in the same plane, irregular moons don't follow the rules. Their paths are inclined, stretched out, and often chaotic. Some even orbit retrograde opposite to the main direction of their planet's rotation. Why does this happen? The answer lies in capture. Most irregular moons began life as asteroids orbiting the Sun. At some point they wandered too close to a planet and were caught by its gravity. Instead of continuing around the Sun, they became trapped, at least temporarily, as moons. It's a cosmic game of chance, and in the outer solar system, the gas giants have been very lucky. But what about Earth? In early 2020, astronomers announced something remarkable. Earth had a second moon. Its name, 2020 CD3. Now before you rush outside to look for it, there's a catch. This mini moon was tiny, only about 2 to 4 meters across. That's the size of a small car. And it was incredibly dark, a carbon-rich asteroid as black as wet asphalt. Hardly the bright companion we're used to seeing in the night sky. Scientists believe 2020 CD3 was captured around 2017, pulled in from its orbit around the Sun. But unlike our main moon, this was never a stable partnership. Its orbit around Earth was messy, looping and shifting, constantly influenced by the tug of the Sun. Astronomers predicted that by April 2020, the asteroid would escape again, flung back into solar orbit. And that's exactly what happened. This wasn't the first time either. Back in 2006, a similar asteroid named 2006 RH120 stayed with Earth for less than a year before drifting away. So, for brief moments in history, Earth has indeed had more than one moon. But these visitors are fleeting cosmic hitchhikers who never stay for long. But the story doesn't end there. Farther out, at a distance of about 9 million kilometres, there is another object, asteroid 2016 HO3. At first glance, it looks like a moon. It circles around Earth year after year, but in truth, it is orbiting the Sun, not Earth. Its path just happens to mirror Earth's so closely that it appears to dance alongside us. Sometimes it pulls ahead, and 6 months later, it falls behind. Objects like this are called quasi-satellites. They are companions influenced slightly by Earth's gravity, but never truly bound to us. At the moment, astronomers know of at least 5 quasi-satellites tied to Earth in this way. It's a reminder that the boundary between moons and non-moons isn't always so clear. Some companions are permanent, others are just shadows drifting in resonance with our orbit. So why do the giant planets keep so many irregular moons while Earth struggles to hold on to even one? The answer lies in a delicate balance of gravity. Every planet has a region of space where its gravity dominates over the Sun's pull. This region is called the Hill sphere. Within it, moons can survive as satellites. But the closer a planet is to the Sun, the smaller its Hill sphere becomes. For Earth, the Hill sphere extends about 1.5 million kilometres. That may sound vast, but compared to the gas giants, it's tiny. Neptune, for example, though far less massive than Jupiter, has a hill sphere that stretches tens of millions of kilometres, a huge net capable of capturing stray asteroids. Earth's net is much smaller, and unless a captured object's orbit is tamed perhaps by the gravitational influence of our large moon, it simply won't stay. Instead, the sun eventually pulls it free. This explains why we don't have a collection of irregular moons buzzing around our skies. Our cosmic backyard is just too close to the sun's overpowering gravity. So does Earth really have more than one moon? The answer is both yes and no. At times we host temporary companions like CD3. We also travel with quasi-satellites, silent partners orbiting the sun alongside us. But in the end, only one, our familiar moon, has proven permanent. Perhaps that makes it even more special. A single steadfast lantern in our sky, while others come and go like passing shadows. And who knows, maybe one day another will stay for good. Until then, we'll keep watching. Thank you for joining us on this exploration. If you enjoyed uncovering the mysteries of Earth's moons and their fleeting companions, don't forget to subscribe so you won't miss our next cosmic journey. There's always more to discover, and together we'll keep mapping the stars, the planets, and the endless wonders beyond. Until next time, keep your eyes on the sky and let Cosmic Compass be your guide to the universe.